let's talk about Math Talks. You may have heard of them, you may not, but I'm here to tell you that Math Talks are one of the most beneficial things you can do in your math classroom. They take 10 to 15 minutes with little to no prep, and they have truly powerful results. So what is a Math Talk? It's basically a prompt that has something to do with math. Students are shown the prompt and have a chance to think and come up with an answer. This could be something as simple as counting a collection of objects or solving a complex equation in their heads. Afterwards, students share their answers and also they share their solutions. So Math Talks are great for improving problem solving and critical thinking skills, and they allow students to learn new strategies and see math from different points of view. They also get practice explaining their thoughts and putting their thoughts into words for others, which is a really important skill. So the best way to show you how to do a Math Talk is to demonstrate it. What follows is an animation that shows you a few different Math Talks so you can get a good idea of how to use this in your math class, and hopefully you'll also see how powerful this is as a tool to help your students truly succeed at math.
When first introducing Math Talks to your students, make sure they know the expectations. When a prompt is shown and a question is asked, students should think quietly and then place a thumb up at their chest when they have an answer. They should not raise their hands when they have an answer. This makes the rest of the class feel rushed, and they'll rush to choose an answer without really thinking about it. After you see all of the thumbs up at the chest, you call for volunteers, at which point students will raise their hand if they want to share. Make sure students know that all answers are good answers and that they shouldn't be afraid to share an answer even if they think it might be wrong. There are still lessons to be learned from wrong answers. Sometimes we learn more from wrong answers than we do from right answers, especially during Math Talks. Present the prompt. In this example, we have a dot count. Students are asked, how many dots are there? Then, after coming up with an answer, they'll place their thumb up at their chest. When you see all of the thumbs up, you can call for volunteers to share their answers. Then, you can call on specific students to share how they came up with their answers. Mandy, how did you know there were 8 dots? I saw that there were 3 on top and 3 on the bottom, so that's 6. Then I added 2 more from the sides, and that's 8. Awesome! That's a neat way to look at it. Ben, how did you know there were 8 dots? I just counted them one by one. Okay, where did you start counting? The one on the top left. This one? Okay, then what? Then I did the one to the right of it and worked my way all the way around. Like this? Nice strategy. Carla, how did you count the dots? I knew that if there was one more dot in the middle, it would be 9, but that dot was missing, so there were only 8. Interesting. How did you know that would be 9? Because it's like a 3x3 array. 3 rows of 3, which is 9. And you knew one less than 9 was 8? Yep. So cool. I love that strategy.
You can see how something as simple as counting dots becomes a really powerful mental exercise. Students get a chance to see math from different perspectives and share their own thinking with others. Here's another simple example.
How many cookies could be in this bag? Come up with a good estimate. Thumbs up at your chest when you have your answer. Raise your hand if you want to share your answer. Carla, what'd you get? 10. Louie, what'd you get? 20. We have 9, 12, 8, 15, 25. These sound like some pretty good estimates. Who would like to explain their thinking? Louie, how'd you come up with your estimate? Well, you can see 3 on the top of the bag, so I pictured groups of 3 cookies going all the way down. It looks like you could fit maybe 5 layers of cookies, so that's 5 groups of 3, which is 15 cookies. That's a really good strategy for estimating, Louie. Who else wants to share? Sam? I thought there would be more like 20 cookies in the bag. Why'd you think that? Well, because the bottom of the bag is wider than the top. So Louie's strategy works if it was all the same width, but it looks like you can fit more cookies at the bottom than at the top. Now come up with an estimate that's too high. Wait for all the thumbs to come up and then call on volunteers to raise their hands and share. 1,000 would be way too high of an estimate. How do you know that's too high? Because I can see 3 cookies at the top of the bag. Just looking at the size of the bag, I know I could never fit 1,000 cookies in that bag. Repeat this with an estimate that's too low. 2 cookies is too low because we can see that there are 3 cookies in the bag. There can't be 2 cookies if there are already 3 cookies. That's a good point, Tanya. Ben, what's your too low estimate? 0. How do you know there can't be 0 cookies in the bag?
Math Talks can even incorporate your current topic of study. Here's one that deals with area and perimeter.
The teacher reads the word problem aloud to the class and then asks the question, which pen do you think is the best for Lena's dog? When all the thumbs are up, she calls on students to share their answers. The 1x5 pen, the 3x3 pen. She then calls on volunteers to explain their reasoning. The pen that's 3 meters by 3 meters is the best choice because it has the largest area. It has an area of 9 square meters, so that's the most room for the dog to run around. I think the 1x5 is the best one because it's the longest, so that way the dog can run for a longer distance before he has to turn around. I picked the 3x3 pen like Carla, but I didn't think about the area. I just liked that it was shaped like a square and it looked like the dog would have the most room in that pen.
You can see how prompts like this provide great practice questioning the reasonableness of answers, especially in real-world scenarios. This is great for improving performance on word problems, and students may even begin to second-guess their own answers after hearing the thinking of their classmates. This next example is often called a number talk. This one is a bit more advanced.
Students solve this equation in their heads and then share their answers when called on to do so. Next, the teacher chooses volunteers to share their strategies, explaining exactly how they solved this problem in their heads and came up with their answers. I got 400. I know that 4 groups of 25 is 100 like quarters when you're counting money. So 16 is 4 groups of 4. So we have 100 4 times. That's 400. I got 380. I broke the 25 into 20 and 5, and then I did 20 times 16, which is 320. How did you know 20 times 16 is 320? Because 2 times 16 is 32, and then I just put a 0 on the end to make it 20 times 16. So then I needed to do 5 times 16, which is 60, and then I added those together. 320 plus 60 is 380. The teacher should be writing all of this on the board step by step as the student explains it. But I'm just realizing that 5 times 12 is 60, not 5 times 16, so I think my answer is wrong. I use doubling and halving. I just doubled the 25, so 2 times 25 is 50, and then I have the 16. Half of 16 is 8, and then 50 times 8 is 400, because 5 times 8 is 40, so then you just have to put another 0 on the end, and you get 400.
I hope you have a better idea of what a math talk is and how to use it with your students. In the description, I've linked a free resource you can use with 15 free math talk prompts to get you started. Please let me know in the comments, have you ever done a math talk? Are you planning to try them with your students? I would love to hear from you. And of course, please like and subscribe to my channel, La Fontaine of Knowledge, for more great teaching tips and tricks.